1.2. Why is testing necessary? Testing as a form of quality control helps in achieving the agreed-upon test objectives within the set scope, time, quality, and budget constraints. Testing's contribution to success should not be restricted to the test team activities. Any stakeholder can use their testing skills to bring the project closer to success. Testing components, systems, and associated work products, for example documentation, helps to identify defects in software. The typical test objectives are evaluating work products such as requirements, user stories, designs, and code, causing failures and finding defects, ensuring required coverage of a test object, reducing the risk level of inadequate software quality, verifying whether specified requirements have been fulfilled, verifying that a test object complies with contractual, legal, and regulatory requirements, providing information to stakeholders to allow them to make informed decisions, building confidence in the quality of the test object, validating whether the test object is complete and works as expected by the stakeholders. Test objectives can vary depending upon the context, which includes the work product being tested, the test level, risks, the software development life cycle being followed, and factors related to the business context such as corporate structure, competitive considerations, or time to market. Testing provides a cost-effective means of detecting defects. These defects can then be removed by debugging a non-testing activity, so testing indirectly contributes to higher quality test objects. Testing provides a means of directly evaluating the quality of a test object at various phases in the SDLC. These measures are used as part of a larger project management activity, contributing to decisions to move to the next phase of the SDLC, such as the release decision. Testing provides users with indirect representation on the development project. Testers ensure that their understanding of users' needs are considered throughout the development lifecycle. The alternative is to involve a representative set of users as part of the development project, which is not usually possible due to the high costs and lack of availability of suitable users. Testing may also be required to meet contractual or legal requirements or to comply with regulatory standards. 2.2 Testing and Quality Assurance (QA). While people often use the terms testing and quality assurance (QA) interchangeably, testing and QA are not the same. Testing is a product-oriented, corrective approach that focuses on those activities supporting the achievement of appropriate levels of quality. Testing is a major form of quality control, while others include formal methods, model checking and proof of correctness, simulation and prototyping. QA is a process-oriented, preventive approach that focuses on the implementation and improvement of processes. It works on the basis that if a good process is followed correctly, then it will generate a good product. QA applies to both the development and testing processes and is the responsibility of everyone on a project. Test results are used by QA and testing. In testing, they are used to fix defects, while in QA they provide feedback on how well the development and test processes are performing. Human beings make errors, mistakes, which produce defects, faults, bugs, which in turn may result in failures. Humans make errors for various reasons such as time pressure, complexity of work products, processes, infrastructure or interactions, or simply because they are tired or lack adequate training. Defects can be found in documentation, such as a requirement specification or a test script, in source code, or in a supporting work product such as a build file. Defects in work products produced earlier in the SDLC, if undetected, often lead to defective work products later in the life cycle. If a defect in code is executed, the system may fail to do what it should do, or do something it shouldn't, causing a failure. Some defects will always result in a failure if executed, while others will only result in a failure in specific circumstances, and some may never result in a failure. Errors and defects are not the only cause of failures. Failures can also be caused by environmental conditions, such as when radiation or electromagnetic fields cause defects in firmware. A root cause is a fundamental reason for the occurrence of a problem, for example, a situation that leads to an error. Root causes are identified through root cause analysis, which is typically performed when a failure occurs or a defect is identified. It is believed that further similar failures or defects can be prevented or their frequency reduced by addressing the root cause, such as by removing it.